boom. All right, so we just continuing from the last video. Just a quick wind up because the time was running down and I didn't want to keep talking and then the equipment shut off. Right, long story, but I'm working within certain boundaries for the time being until I upgrade the equipment. All right, so just to finish the discussion, remember that x is always the first coordinate when you're doing coordinate geometry, in the same way that your latitude is always first when you're doing your geography. All right, so a point in this, let me see, let me change up the colors a little bit now. Right, I could rub off that thing in orange, right, because that is kind of not really necessary right now. The people in AdMaths, however, if you're doing AdMaths, that knowledge will be very, very important. All right, remember the quadrants are designated anti-clockwise, first, second, third, fourth. So if I have another point, let us say the point Q. Let us say the point is the point Q. A random point, Q. Right? Let us say that the distance of Q from here, so the distance, this distance here, let me say that distance is 4. So this distance here, that's the point 4. That distance is 4. And let me say this distance here is 1. Well, it's 1. The distance is 1. But because the distance is down, it will be minus 1. So the point Q will actually be the point now 4, minus 1. All right? Let us say we have another point, PQR. Let us say we have a point R. All right? And let us say, for the sake of argument, that the distance of R from the y-axis, which is to say the distance, this distance, is, let us say that distance is 7. So this will be 7 here. And let us say this is minus 1 here. All right? And let us say that this distance here, this distance here is, let me say, minus 2. Minus 2. Minus 2? Yeah, minus 2 because it's down. So this is the distance minus 7. The only thing the minus sign means here is that the distance is measured to the left of the origin. And similarly, this distance here is minus 2, which is to say that it is measured down from the origin, so that the point R would actually be, R would be the point minus 7, minus 2. All right? And by the same token, let me say we have PQRS. Let me say we have a point S somewhere. Let me see, let me bring it out closer now. Let me bring it real close. All right? No, let me bring it, carry it up a little bit. Yeah, let me bring it real close. Let me bring it real close. Right? So let us say, for the sake of argument, that this point S is, we can rub off the map here now. All right? We're not in geography land anymore. Let me say that this point is 1 unit away from the y-axis, which means that along the x-axis, the distance is minus 1. The minus sign, of course, signifying that the distance is measured to the left of the origin. And let us say that the distance here is, let me say, 3 up from the y-axis. So the distance of the point from the y-axis is 3, and this is the point 3 here. So the point S will be the point S brackets minus 1, 3. So I'm doing all of this so that you can see exactly how the thing is done. You can see how I write it out. Notice that in every case I put a capital letter followed by the coordinates in bracket. The x coordinate first, y coordinate. That is the convention. That is how you write points in coordinate geometry. So P 10, 5, the both coordinates are positive. That is what happens in the first quadrant. In the second quadrant, the x coordinate is negative because you now move into the left of the origin, and the y coordinate is positive because it's still going up. So this would be the point minus 1, 3, s minus 1, 3. In the third quadrant, the x coordinate is still negative because we move into the left of the origin. So the x coordinate of this point is minus 7. And because the point is below the origin, it will be minus 2. We're going down. So 2 down is minus 2 when you're writing it in coordinate notation. So r, the coordinates of r is minus 7, minus 2, which is to say that the point r is located 7 units to the left of the origin and 2 units down from the origin. All right? And of course, we go to our point Q. Same story. In this case, the point Q is 4 meters perpendicular from the origin. All right? This line is in line with the origin, and the perpendicular distance is 4. Similarly here, this line is in line with the origin, and the perpendicular distance is 1, but it is 1 below this x-axis, and this distance is 4 to the right of the y-axis. So 4 units to the right of the origin will give you an x coordinate of 4, and 1 unit below the origin is minus 1. So Q is 4 minus 1. All right? So that is just to understand the coordinates, so that when you're doing the exercises accompanying this video and the one before it, where the exercise is just to identify points. So you'll see points in the diagrams, and you will be asked to identify the points. That's just a basic practice, because if you cannot do that, then coordinate geometry will be a problem, because this is the beginning, this is the foundation. Everything else, as with all other topics, will get more complicated, but as with all other topics, you start from the simple stuff and you build up. All right? You might be curious in terms of finding out the exact distance from the origin. Fine. So if the coordinates is 10 away from the origin in this direction, and 5 away from the origin in this direction. So in other words, P is 10 units away from a line drawn to the origin, a vertical line, right? So vertical is y, horizontal is x. And P is also 5 units away from a horizontal line drawn to the origin. Then the actual distance of P from the origin will be this line here. All right? Which, if you notice, this line, now we call this the point O. Yes, the origin is always denoted by the letter O. All right, and the coordinates of O, just to be sure, is 0, 0. All right. So the actual distance of P from O is the length of the hypotenuse. See that word again? For those of you who have gone through the Pythagoras theorem and the trigonometry, is the length of the hypotenuse of this right angle triangle. Because everything here is right angles. The y-axis and the x-axis form a right angle at the point where they intersect. Just like the equator and the Greenwich meridian. They intersect at right angles. Alright? So any distance we measure of this point from this line is a perpendicular distance, and any distance we measure of this point from this line is also a perpendicular distance. So this here is a right angle, that is a right angle. So this is a right angle triangle. This here is also a right angle triangle. All right? So of course, if we have to actually find the actual distance of P from O, we will then of course be invoking Pythagoras theorem. Right? And I'll just write it out, but I'm not going to work it out because we're not really here for that right now. We will get into that into a little more detail later on. So the distance of P from O, which is the distance OP, right? OP is equal to the square root of this distance here, 10 squared plus 5 squared, which is this distance here. And he just worked that out accordingly. So if I would have lost you at this point in discussion, don't be intimidated, don't be fearful. All right? The most important thing at this stage is to just be able to recognize a point on a graph, recognize a point in a diagram, and I have absolutely full and total confidence that you could do that. All right? Once you see the diagram and you see the points, you know right is positive, left is negative, up is positive, down is negative, boom. You could recognize the points. And the way the exercises in this platform are structured is that you have the answers. So if you get a diagram and you're not sure, and you take a peep at the answers, and you see the answer, then the next step now is to reverse engineer the whole process and figure out, well, why the answer is 3, 1. And then you realize, well, it's 3 to the right of the x-axis and 1 up from the y-axis. No, 3 to the right of the y-axis, sorry, and 1 up from the x-axis. That kind of thing. Sometimes you may not even have the vocabulary to explain what you understand, in terms of if somebody walk up there from the street and ask you to explain why that point is 6 minus 5. You might be able to explain it. You might be at a loss for words. And that is okay. The most important thing is that you understand it. And that if somebody asks you a question in mathematical language, you could answer them. So even if you can't make the shift of explaining the mathematical concepts in English, then just do it in maths now. Even if you feel that you can't really explain it, you just do it. And as you continue to do it, and as you continue to expose yourself to it, eventually you will find that you're able to put more and more things into words as you go along. So don't rush the process. The important thing is that you had to understand it inside here. And that if you see a diagram and ask you what a point is, you can say, well, a point is minus 3, minus 10. Right? So you have a whole set of questions just to do that at this stage of the game. And of course, once we establish that you could do that, then we go a little further, and a little further, and a little further, and a little further. That's how we do the thing. That's how we approach it. All right? So the talk was a little long, and again, it was a little longer than you'll get in most other places with most other people. But that is generally how I do what I do. We talk it out. We try to break it down so that people could understand that, yes, there will be certain times when sometimes the talk might get a little complicated. All I want you to do is not be intimidated, not be fearful. If you tell me that, okay, I don't understand this part of the discussion, fine. I could work with that. All it means is that at some point later on, I will have to come back there and take this alone and make that into a whole separate discussion all by itself. All right? So whatever you don't understand, just make a note of it and rest assured that we will deal with it at a later date. That's what we're here for. All right? So enjoy the exercises. All right? Coordinate geometry is one of those really, really important topics, and that is one of the topics on the C6 syllabus where people start to stick, where people start to get stuck. So I want to encourage you to take your time. Take your time. This is not a topic to rush through. All right? So That's it for now. Enjoy the exercises, make sure and do them, and we will continue our march forward in the topic of coordinate geometry and, by extension, in the whole CSEC mathematics syllabus.